And we are live. Good evening, everyone. Welcome to the live chat for Tuesday, April 15th, 2025. Doing it a day earlier as we get ready for the holiday season. Of course, we're talking about Passover and Easter. I'm not sure if there's any other holidays, but there are. Hey, have fun, right? And have plenty of feasts and all that good stuff. So, of course, we have a lot of people traveling, so I'm getting a lot of questions about that. And I do plan on covering a lot of that, including some interesting questions about the MJO, which I'm going to cover as well. But before we go on to our regularly scheduled programming, we do have a little bit of breaking news. The budget for the National Weather Service has just come out publicly, and they are providing the same amount of money that is equal to last year. So why are we seeing all these cuts then? Well, what they're saying is that at this level, NOAA should make efforts to streamline operations and eliminate inefficient or unnecessary functions in order to best serve the American people. So they're supposedly trying to streamline everything. I mean, they could just say we're going to get rid of the GFS and replace it with something better. That alone would improve NOAA significantly. But what they're planning on doing, and I want to share this because, there's going to be a lot of people sharing all sorts of interesting takes. So I'm just going straight from the text. The passback provides a lot of money, over 171 million for OAR programs. That's basically your forecasting programs. 484 million reduction from 2024 enacted passback eliminates all funding, and this is probably where people are going to get ticked off, for climate, weather, and ocean laboratories. So a lot of research and experimental studies and cooperative institutes. Now, that doesn't mean that those institutes are going to disappear from the face of the earth. They might go private sector, but it certainly means that the federal government isn't looking to fund these. And also, it does not fund regional climate data information, climate cooperative research, Sea Grant for college and agricultural, or national oceanic partnership programs. So what they're going to do is funnel all the money that they lose last year into improving radar, improving research for tornadoes, basically a lot of NOAA focus and model focus technology. So they're moving away from the climate and focusing more on the weather. Now, understand with this latest news that literally just came out roughly 10 minutes ago, a lot of this, well, all of it has to get approved by Congress. So, yeah, the executive branch can move people around, let people go, but only Congress can approve the budgets and approve the ideas. So, there's going to be a lot of changes here before we get too much into it. But that's the latest breaking news on that. I know a lot of people asked me about that. There's a lot of talk about what's going on with NOAA, National Weather Service, and all that good stuff. So there is the latest information. Does that mean that maybe they're going to rehire more meteorologists uh, in some of our local field offices? I don't know. And I'm not going to speculate, but that is the latest news, and that is what is going on with the budget. We'll see how that plays out. Book of the week. This is an old one. It is a beautiful one, and it's one that's helped me out quite a bit when I am preparing and working on my CCM test. That, remember, is open book, but believe me, you need all the books you can get with all the math and whatnot involved. Now, with that, this is John M. Wallace and Peter V. Hobbs Atmospheric Science Introductory Survey. Okay, and you can find this again on Amazon and on the AMS website. And if you could just Google it, you can find it as well. This is one of the first books I got. This is like my Met 101 book in college. And it was one that I thought at first, like, oh, geez, I know everything about basic meteorology. But there's a lot of stuff in here, like the basic chemical equations for water and a lot of ways to break it down and how it works with different aspects of the equations that you're going to start learning, magnetic fields, the development of thunderstorms and how lightning develops. So this is an excellent book. Now I'm sure they probably have new editions. I have a very, very old one. In fact, let me see. When did this one come out? Um, Oldie but goodie. Copyright 1977. So 2 years before I was born. But it actually helped out quite a bit. So if you're looking to start out, if you're looking to challenge yourself and going beyond just, hey, this is what an L on a map is, I would definitely suggest that book. Again, I'm going to see John M. Wallace, Peter V. Hobbs, Atmospheric Science, an Introductory Survey. So there we go. So that is the book of the week. Now I already saw some questions about the MJO, and I figured this is a great time to cover the MJO because, well, let's face it, we're going to be talking about quite a bit over the next couple of months. Why? Because we don't have a La Nina, we don't have an El Nino. It is as neutral as it could possibly be, and likely it's going to stay that way through the rest of the warm season, spring and summer, and probably into the fall as well. So that means your primary tropical influence is going to be the MJO. Now, when the MJO is strong, well, the forecast is easy because it's a dominant influence. When it's neutral and weak, it is, well, as you can see, I don't have much hair left, so you can see what it could do to you. In this case right now, the MJO forecast is expected to go into, well, it's going from a neutral state into phase 7. All right, so in a phase 7, how do I use this? Well, it's not as simple as saying MJO phase equals A, right? Because you have to take an account of other factors in the atmosphere influencing the MJO. And some of those factors influence the MJO itself. So there's a lot of, I guess you could call it technical and chaotic factors involved, and you're never going to get a 1-to-1 ratio. But in order to understand the MJO, let's go look at some of the technical data. Now, first of all, I just want to show you from the cpc.nsep.noaa.gov, you can go right into the MJO link. And if you scroll all the way down below all the flashy graphs, you can come down here for yourself and you can read all of this information here. You probably want to start off, and we'll do this tonight, with the one-pager fact sheet. Okay, very basic. The MJO detailed information PDF, and of course you have all these publications, and of course there are books like this one, in fact, and other books, of course, which we'll share over the next couple of weeks that will go over the MJO as well. So there's a lot to research and read up on the MJO, but if you're just looking for a free basic overview, this is a great place to start under NOAA. So let's go check out that one pager. Okay, and I'm just going to read this off, and then feel free to visit anytime you like. So this is from NOAA NCEP Climate Prediction Center, John Gottschall. I'm probably mispronouncing that wrong. Wayne Higgins, excellent meteorologist. Okay, what is the Madden-Julian oscillation? As we call it, the MJO. The Madden-Julian oscillation is a tropical disturbance that propagates eastward around the global tropics with a cycle on the order of 30 to 60 days. The MJO has a wide range of impacts on the pattern of tropical and extratropical precipitation. Tropical is tropical storms, hurricanes, extratropical cold fronts, nor'easters, stuff like that. Atmospheric circulations, like El Nino, La Nina, and surface temperatures around global tropics and subtropics. Now, tropics are, well, tropics like the Caribbean. Subtropics, Florida, Gulf Coast. And also, some temperate climates as well, like the northern mid-Atlantic, like ports of New England, the northern plains, central plains. As you go further up in latitude, the impacts reduce. Okay. but there's still some factors involved in it. It does not create, this is very important, it does not cause El Nino or La Nina, but can contribute to the speed of development and intensity of El Nino or La Nina. So think of the MJO as kind of like a steroid, okay? The El Nino or La Nina develops, and depending on the state of the MJO, it can enhance and amplify the El Nino or La Nina influence. How does the MJO activate activity vary over the course of the year? This is where it gets fun. The MJO is often quite variable. So when the MJO is your primary forcing mechanism, it can create a lot of havoc in your seasonal forecasting because it changes frequently. So with periods of moderate to strong activity followed by periods of little or no activity. So obviously when it's strong, the influence of the MJO on the 500 millibar pattern and the pattern overall is pretty clear. But when it's weak, well, that's when you get a lot of volatility involved. Because the MJO impacts all well-known, especially especially in the global tropics, okay, periods, when the MJO is active offer opportunities for enhanced National Weather Service climate prediction and decision assistance. So basically, the stronger it is, the easier the forecast is because the dominant influence is so obvious. Typically, the Northern Hemisphere, late fall, winter, and early spring have the greatest level of MJO activity. Why? Because you have so many different clashes of air masses interacting with the tropics, and the MJO waves are interacting with the polar jet stream far more frequently because the polar jet stream is further south. So you're seeing a lot more interaction. How does the MJO change during the ENSO cycle? Overall, the MJO tends to be most active during ENSO neutral years. See, told you, it's going to be crazy. And is often absent during moderate to strong El Nino and La Nina events. I wouldn't say absent. Okay, let me tweak this a little bit. El Nino and La Nina is such a powerful influence on the 500 millibar pattern that it overwhelms the MJO. The MJO is still alive and kicking, it's influencing, but the El Nino or La Nina event is like a huge tanker, and the MJO is kind of like a speedboat. Okay. So when you're comparing the wake of each of these boats, the tanker is going to have a lot more influence and basically cancel out a lot of the influence of the speedboat. Now, at times when the speedboat and the tanker wake is aligned, the waves are even larger. The MJO doesn't completely disappear, but it just gets overwhelmed by some of the factors. The MJO activity during late 2007, early 2008, which occurred during La Nina conditions, is unusual but not unprecedented. So here's the thing to really consider as we deal with more climate influences, climate change, what have you, is how much of an interaction between the MJO waves and the El Nino and La Nina effects start to play out. When it comes to meteorology, there is no steady state. Okay, it's a mirage, it's a lie. So you always have to be aware that, well, the atmospheric evolution is always changing, and you better be aware of it so you can change with it. What are typical MJO impacts on the United States? The MJO influenced both precipitation and surface temperature patterns across the U.S. The two most significant impacts over the U.S. during Northern Hemisphere winters are in an increase in frequency and intensity of heavy precipitation events along the U.S. West Coast, and an increase in frequency and intensity of cold outbreaks across the eastern United States. Remember, we were watching over the winter where the MJO was going, phase 7, 8, 1, 2. Well, this is part of the reason why. The MJO also influences tropical cyclones. Watch out for phases 8, 1, and 2 for the Atlantic. tropical cyclone activity in both the eastern Pacific and the Atlantic basins during the northern hemisphere summer. And believe me, that's going to be a big factor when we study the tropical Atlantic. Now, the way I use the MJO is I like to use a weighted version depending on the pattern. So you want to use the significant scales. Obviously, the lowest, the lower the influence, right? So first of all, we go through to the 3 month period. So let's see, we're in April. So you use the March, April, May feature right here. As you head towards the end of April, you can start to shift more towards April, May, June, but that can be a little bit tricky. So you use this and you find out what phase you're in. So let's say we're moving into phase 7, and that looks cold, right? Okay. But how much significance does that have on the weather pattern typically? Well, as you can see here, if we are forecasting for the desert Southwest, not so much. Forecasting for the Ohio River Valley and the Mid Atlantic, a little bit more of an influence. Okay. But you can't just use temperatures, you also have to use precipitation. And so you do the same thing. Here's our composite already set up. And again, phase 7 is rather wet. What are we forecasting for? Well, I'm going for a wetter pattern, but a lot of the model guidance is also going more towards a near normal rather than below normal. So why isn't it going below normal? Well, the reason why is simple. You cannot use the MJO standalone. You have to consider other factors involved when creating this forecast. So you want to take a look at not only the state of the MJO and how strong it is, which tells you how much influence it has on the 500 millibar pattern, but also what else is going on in the atmosphere. Like, for example, our fading stratospheric warming and how that's influencing the polar jet stream and how that might adjust or shift the weather pattern based on those factors. So it's a piece of the puzzle, but not the whole puzzle. A very important piece, don't get me wrong, especially this spring and summer, but not the all in all 100% dominant factor, and then that's it. A lot of people like to jump to conclusions on that, and that can lead to a lot of mistakes. Another composite that we're going to be studying quite a bit during the tropical seasons is the MJO. I like using the surface, pressure, and precipitation. So when we study phase 7, 8, and 1, there's an increase in precipitation potential over the Atlantic and around the Caribbean. Now, understand you do not, I repeat, you do not take this verbatim. All you really do is say, hey, the MJO is moving into a favorable phase. We could see an uptick in activity. Anyone that uses this and then tries to pull off some sort of hurricane forecast via the CFS or some nonsense like that is simply looking for clicks and for following and hype and whatnot. All you can really do with this data is say, hey, look, the weather pattern will become more favorable. And that's it. That's where you end the discussion. So that's a little bit on the MJO. Now let's take a look at our weather pattern over the next 15 days or so. And we already know that the MJO is the dominant tropical forcing, but what about the stratosphere? Well, the stratosphere is moderating. Now, part of this is because we're getting more direct sunlight, so we're losing our anomalies, the strength of the anomalies, because we no longer have a cold stratospheric environment just because of the time of year. So, because you're losing the gradient, you're losing the influence on the polar jet stream, and the polar jet stream starting to lift northward. All these things are typical. But this year we ended the cold season on a very warm note in the stratosphere, which has kind of left kind of a ghost. So you can see how everything's kind of faded here. See that? See how it's fading very gradually? Well, think of it kind of like an echo in the atmosphere. And so this echo is going to be a real pain in the neck in driving lingering high latitude blocking, and that means our negative NAL. Now, typically, I use a 500 millibar heights, but I want to use 500 millibar PVA here to kind of show you the short waves and how all this is playing out. So let's jump out to 5 days out. And some of the themes involved here. First of all, below normal heights towards the northwestern Atlantic, not really a true negative NAO, but statistically speaking, it would be considered, it could be considered a negative NAO. Then you have this signal here, which is typical of an MJO phase 6-7, okay, with some influence of a trough around the Western Canada and a very fluctuating polar jet stream over the Pacific. You end up with a storm track towards the plains and heading up towards the eastern Great Lakes. I am rather concerned for the rest of this month into early May for a lot of severe weather in the Southern Plains, Central Plains, Mississippi River Valley, Upper Midwest, Ohio River Valley, and Tennessee River Valley. And you might be able to throw in the Gulf Coast as well. For us, though, because we have this signal here, it shows up day 5, day 10, day 15, this weakness here, you end up with your strongest short waves lifting up towards the St. Lawrence River Valley. And you kind of get this ghost-like remnants of PVA, and you can see it all the way through the forecast period over the mid-Atlantic. So this is very similar to just weakening showers and thunderstorms. Active precipitation event, but not well above normal. No major storms, but a lot of hit and miss showers and thunderstorms. I do not see this as a severe weather pattern for us, but like I said, further to the west, if you have friends and family out to, let's say, Arkansas, Illinois, Indiana, Kentucky, yeah, they're going to have a bit of a rough ride in this weather pattern. And the reason why is that in this type of setup, you constantly have modified polar air masses and Pacific air masses dropping into the Rockies and capable of interacting with the moisture coming out of the Gulf. And so what you end up with is a nice clash over the plains and a lot of activity. Now, again, you don't want to go verbatim on any of this information. You kind of want to take a step back and just say, look, pattern's going to get active in these areas. So we'll see how everything plays out and how that works out. As for now, winds are finally starting to die down. The cold front has cleared off the coast. We had some pretty strong wind gusts earlier on and some thunderstorms or thunder showers, producing a little bit of hail. So why are we seeing everything weaken now? Well, as you can see on our radar, you can see a lot of these showers and thunderstorms starting to fall apart on our weather top radar. Let's refresh this. Notice they're starting to fade. So what's going on here? Well, we had the strong winds because we had some pretty good winds at the mid-levels, 850 millibars. And while that was happening, we had pretty good instability. Now, this is about 4 hours ago, so this takes us to about 4:23 when the winds were really starting to pick up. This is low-level instability, okay? So you have a pretty impressive, when you have a lapse rate at the lower levels at 9.5 degrees, that's pretty impressive. So what we saw this afternoon was maximized mixing of the atmosphere, mixing down those mid-level winds down to the surface, which caused strong wind gusts even outside of thunderstorms. And then the thunderstorms that developed, well, let's take a look at the skew T out ahead of this. This is from earlier on this afternoon, and you could see all you need is a little bit of lifting to lead to a little bit more moisture and get that LCL a little bit closer to support your thunderstorm development. But out ahead of any potential thunderstorms, you could already see the atmosphere was pretty unstable. It just needed a little trigger, just needed a little bit of push. See this dry air up here? Well, this would definitely support a signal of the potential for what we call low top thunderstorms. And you can see these winds here. Well, this is what's going to be mixing down. This is what did mix down and create our strong wind gusts. Once the instability in this environment goes away because our temperatures are falling off back into the 50s, then you lose all the dynamics. So this is why your strongest winds happened right around towards the later part of the afternoon, where we maximized our instability, maximized our lifting, and allowed for these strong winds to get mixed down. And in the case of a thunderstorm, I got this set up earlier on in the afternoon when we started to see some thunderstorms moving through northern New Jersey. This is what this basically looks like. You have pretty good steep lifting here, very, very strong lapse rate. And so this would allow for thunderstorms to grow, but kind of get cut off. And you can see the mixing that was in place here, getting ready to mix down towards the surface. And of course, in this environment with this type of lapse rate, you open up the potential for some small hailstones. And that's what we told. What we did not see was grapple or snow or sleet. Some people were saying, oh, look, it's sleeting. No, sleet is a different process than hail. This is a process of rapidly rising air and a water droplet freezing and then collecting, falling back, and then getting lifted back up into the thunderstorm cloud, which leads to hail. Totally different process than sleet, which is simply just a snowflake that somewhat melted and then refroze into ice. Okay, so it's a different process, so it's not the same thing. So now that is all pushing off the coast. And I have some good news for most of the upcoming holiday weekend. This trough is going to leave. So in the next 48 hours, we have rising 500 millibar heights. You can see on the infrared satellite picture, all strong lifting is exiting out. And on the water vapor satellite picture, there's the base of our trough. When the base of the trough moves over your location, you're chilly, but you're dry because you have convergence and confluence. So that's what we're going to be dealing with tomorrow. Once this starts to lift out, we'll start to see rising 500 millibar heights. And then Friday into Saturday, we have the threat for some showers via a cold front passage. So just kind of showing what that looks like. Again, 500 millibar heights rising. This feature right here will open up the potential for a few showers Friday night into Saturday morning. And then Saturday afternoon, additional showers with this short wave dropping south. But overall, Easter Sunday looks pretty quiet with 500 millibar heights rising again. The mid levels, again, the bulkier potential precipitation looks like it's going to be on basically Friday night into Saturday afternoon. But I'm not really looking at a lot of precipitation out of this. The precipitable water, the moisture transport is not really all that strong. And the precipitable water values are not all that impressive. We have some convective signals here. This looks like a little bit of convective feedback error, so I'm going to take that out. And our temperatures through the period, well, we'll be warming up very nicely on Saturday. It's going to be absolutely beautiful. And then Sunday, on Easter Sunday, actually looks pretty good. So for Passover and Easter, overall, we're not looking at too terrible of a weather pattern at all. Over the next 90 hours, we'll get rid of our pesky showers. Tomorrow is going to be quiet. Thursday, if you're traveling, it's going to be quiet, not much going on. Friday, most of the day is going to be quiet until we get our warm front moving through with a few pesky showers. And then we push on to Saturday, where that's where we have the best potential for some scattered showers. But I'm not looking for any type of heavy rainfall. I see no sign for any type of major storms. And Easter Sunday itself, if you're running out there to try to find some Easter eggs in the morning, you will be fine. No concern whatsoever in that setup. So with that, let's see what questions we have. And of course, first we will check out the latest information, latest questions from premium consulting members, answer all their questions, and then we will go to YouTube and the other social medias. And oh, by the way, the Mets and the Twins are tied currently 2-2. They were leading 1-0, so I'm curious to see what happened there. So let's see here. Hugo, bless you. Hugo asks, how do short waves form? Are those little vorticities that spin around an upper level low? I get that the sun warms the surface and the warm air rises and cold air from the poles comes in to replace it, but perhaps you can go in detail on how these little short waves form if you have time. That is literally 3 months of Met 101. Actually, maybe Met 102. So I'll give the abridged version. short waves develop due to differences in the atmosphere, mass differences. So it could be temperatures, moisture, but it's because of those differences that we get clashes in the atmosphere, right? And then you add in the Coriolis effect of the planet Earth with the rotation, which is why we know that the Earth is round and not flat, by the way, just so you know. So that rotation causes short waves, right? So we have the clash of the air masses. Okay, so you have that rising motion, and then you have the turning motion. So that's how you get your different short waves. That is a very, very basic, very plain um, explanation. To go into far more detail, it'd probably be a class that I would have to teach, which is something that we are working on in the future. Stay tuned. But that's very basic. Okay. Definitely something like this book, would definitely help quite a bit in sharing the equations, the processes, but it's the constant, basically what you're seeing when you see a short wave is a constant approach of the atmosphere trying to reach a balance, but it never does. So that's what you're generally seeing in this when you see a short wave. Card isn't here tonight, so that's probably one of the few questions we'll get. I know him. He always has a ton of questions. I think he comes and creates a list. But it is a holiday, so I'm not expecting a whole deal. Sean Wax, I think I'm saying that right. We already answered your question. Shane Wax, yeah. So I think we answered a lot of this. How does a weak MJO signal become more active in phase 6 and 7 to affect us, and why? A lot of that depends on the evolution of the SOI, Southern Oscillation Index, the difference in pressure and density in the tropics, and also interaction of mountain wave torque over Asia. Right now, we're not seeing any indication of a stronger phase 6 or 7 at this time. Let's see here. You said last week that New Jersey would not get any snow last Saturday. High Point got 6 inches and even got some flurries in Bridgeport. What changed, Steve? All right, so I definitely did say that I was not expecting snow on Saturday, aside from the highest elevations, and that was definitely true. I wasn't expecting anything for, let's say, the coastal plain, although some people did get some flurries. Um, what happened in that scenario was that we had strong mid-level forcing that pushed a little bit further north and enhanced some of the snowfall in the highest peaks over northwestern New Jersey, the Poconos, and Catskills. I didn't think that they'd get 5 inches, but that's why we study meteorology, and that's why you sometimes, well, you're never 100% right. So that's basically what happened. We had the mid level forcing push a little bit further north with stronger frontogenesis. It enhanced some of the precipitation in a few localized areas, and that's how we got the snowfall. Uh, I can't hear him. Oh, there it is. That would stink if I went through all that and they can't hear me. Oh no. I'm going to the Mets game Friday night. What will the weather be? Definitely still a bit chilly. Um, but it should be dry. They'll be fine. I'll have more details once we get closer because I like to look at the evolution the day of, especially around Long Island or around Flushing Bay. But overall, I'm not expecting much in the way of any type of significant impacts that would impact the game. But I would definitely have a pretty good coat because even though you see the forecast temperatures in the mid 60s or upper 50s, anytime you have the wind coming off the bay, it actually feels more like the upper 40s. So it's rough, especially if you're higher up in the stadium. Would Earth's weakening magnetic field affect the atmosphere? And I would imagine the sun also has a big influence via forcing. The sun definitely does. That is a long discussion. We are seeing a weakening magnetic field, nothing that is too out of the ordinary, though. I know that there are some individuals that like to go way overboard and, like, going with the whole poles are going reverse. And yeah, it can and does happen. It happened before, it will happen again. But when it has happened, no, the whole world didn't blow up and earthquakes didn't go crazy and all that stuff. Really, it was barely noticeable the last time it happened. But the sun definitely does have an impact. It has more of a seasonal impact than it does a specific storm impact. You have to look at more in terms of a long-term climate impact. But the evolution of the different phases of the sun, mostly revolving around the sunspots and whatnot, um, does not have a one-to-one ratio impact on the Earth's weather. How will April end up above or below normal? I'm expecting it. Let's see here. I'm expecting the rest of the month to pretty much be near normal. We're gonna have fluctuations of above and below, but I think the overall average is going to be near normal for the most part. So far, that is some pretty good questions. Is there anything on X or Facebook or any of those guys? Okay. It never is. Meanwhile, my Mets are down 4-2, but there's an umpire review. I'm not sure what's going on there. Oh, oh, that does not look like a home run. Well, let's see here. So we answered all the questions on YouTube, and I gotta admit, the Excedrin I took before this is actually finally working. So I was like, we are both battling headaches. How are you feeling, by the way? Yeah, yeah, definitely. I mean, actually, I took the Excedrin migraine, and it seems to be kicking in. Thank God, because beforehand it was not fun. Let's see. Do we have any more questions? Let's see what they are doing. Well, all I can say is this. I'm going to just talk a little bit about baseball for just a second. There was all this nonsense about Soto. I just want to touch on this for just a minute because I do care. I don't care. Just hit home runs. That's how I feel as a Met fan. Let's see here. Any strong winds coming that you know of? I am going to be keeping an eye on some stronger wind gusts possible on Saturday afternoon with the cold air transport. But with that said, I don't see anything like a widespread 50 or 60 mile per hour winds, but more in the 30 to 35 mile per hour winds I'm a little concerned about on Saturday afternoon. Other than that, it's actually going to be pretty quiet. There aren't many strong storms or anything like that. Tired of trees falling on my house and other buildings. I don't blame you. Look, we have trees all around us, and every time it gets windy, we start looking like, oh, but we don't have any trees that are directly on top of us, but it's close enough to be a concern. So that is not fun at all. I can tell you that right now. Right? I swear we get everyone's leaves. We have no trees with leaves, but we get everyone else's leaves. Yeah, we don't have any tall trees. We do have some pretty good persimmons though. That our squirrel and our chipmunk and also all the birds really love. Figs too. That's true. Yep. 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 Can I start my outdoor planting in Bridgewater, New Jersey? Great question. We actually just turned on our water, so I would say in Bridgewater you probably could start planting and getting things going. For the most part, I only see low temperatures in the upper 30s, coldest, but for the most part, we're shifting towards say 40s and 50s. So we're definitely moving in the right direction there. Let's see here. I have had 4 down in 2 different storms. Oh boy, that is not fun at all. I understand. I totally get you. see here. Well, I think we knocked out all the questions. And you know, that's the thing too with the strong winds over the past. There's been a lot made of the strong winds impacting us quite a bit. It's not a surprise when you're considering all the clashes of air masses that we're seeing and the strong upper level lows that are forming over the northwestern Atlantic because of our weather pattern. But I think we'll start to see that back off quite a bit as we move through May and head into June. So we're almost out of the woods. So that's certainly some good news. But like I said, I don't see any type of major storms. Even when I go out to, granted, I don't take anything verbatim 15 days out, but even 15 days out, I just see basic cold front passages. Now, that doesn't mean you can't get a strong thunderstorm here and there, but I don't see any major nor'easters or major windstorms or anything of that nature. So that is certainly some good news and on that front. So hopefully we'll get some improvement on that. So it looks like we answered all the questions, unless we don't have anything on Facebook at all. No. Check again. Well, we knocked out X. We knocked out YouTube. And we knocked out the premium chat. How many wins will the Mets get this year? I would not be surprised they go over 95. Wouldn't be. Well, I appreciate it. Thank you very much. I appreciate it. That is awesome. So I think considering the growing headaches and the fact that we are moving into a quiet weather pattern, don't jinx it. Okay. I'm going to end it early tonight, save some of my energy, and start getting ready to hunt for chocolate by the Easter Bunny. And she's going to make a cup of tea. So we're going to have some tea. We're going to chill out. And as always, I'd like to say, stay safe out there.